We will talk about recommender systems and collaborative systems. So let's look at the problem of what we call as an information access problem. What are different situations that one can think of? So let's look at your information need. In some situations, your information need is stable. It's the same kind of information you want day in, day out. And for certain applications, you need different information at different times. As far as your sources of information are concerned, the source may be stable. That means it's not changing. Or your source might be varying source. It's different each time. All right. So those are some of the possibilities that one can think of in terms of information access. All right. So if you look at the problem of information retrieval, basically it's not the same piece of information you're trying to extract from Google. Every time you go, you're looking for something different. All right. So basically your need is different. So that's why we call it information retrieval. All right. If you look at a data mining situation where you have fixed data that has been collected and then you're trying to mine it. All right. So that is kind of a stable scenario on both ends, what you're looking for and what you are starting with. All right. If you look at the other end, information filtering different each time. Let's look at an example where this applies. Say, for example, you want to keep track of all the scores of our favorite Detroit Lions team. So your information need in this case is stable. You want to keep track of whatever is happening with Detroit Lions. All right. So what you want to do is every day there is always something or the other happening. But your desire is fixed. That is, I'm looking at information regarding Detroit Lions. All right. Today the information is something. Tomorrow something happens. You have some new piece of information. Day after tomorrow they have a game and there is additional information. So basically information is different every time, but you are looking for same stable interest. All right. So basically that is what we call as information filtering. So the difference between information retrieval and information filtering is that in information retrieval, we have different queries. All right. In the case of information filtering, our query is the same, but underlying collection from which this query is being picked up is different. All right.
For example, if I want to check the stock price of Apple every day after day.
Yeah, that will be information filtering. Okay. And in fact, I think I have the next slide, which, okay, so basically information retrieval versus information filtering, if you do. So information retrieval system responds by presenting retrieved documents or links to documents in response to user queries that change according to user needs. Right? You're working on one term paper, you got some query, you're working on another class, another assignment, you have different queries. All right. Information filtering system retrieves documents in response to a fixed user query. All right. So the collection in an information filtering system is dynamic. And what happens is that some of the websites allow you to create what they call as a personalized page. So that personalized page kind of represents an application of information filtering. For example, if you use Yahoo, you can actually customize Yahoo as your personalized page. And on that personalized page, you can say, all right, I'm interested in following a stock symbol. So basically, it will show you their prices every day or every time you go to that web page. And you can also say, all right, I'm interested in some of the stories related to entertainment or sports or whatever. It will pull out that information and present it. So that is what we mean by information filtering. All right. So information filtering is content based. Okay. The filtering is being done looking at the content. So with that background, let's look at what we mean by a recommender system. So when the delivered information comes in the form of suggestions, an information filtering system is called a recommender system. So if you're looking at information through information filtering, you're looking at the Apple price, that's fine, that's information filtering. But if the system comes with additional recommendation, says, well, the price is good, you should buy it, then that becomes a recommendation system. All right. So a recommendation system uses collaborative or content filtering to personalize product predictions for users. All right. And one of the biggest users of recommender systems is Netflix. And basically, this slide shows you that Netflix had created $1 million grand prize, and that is about 15 years ago. Okay. So they wanted to have an algorithm that will suggest to their subscribers what movie they should be watching based on what they have watched so far and a couple of other things. All right. And they needed they already had an algorithm, but they needed something much better. So they created $1 million prize and opened up their data at that point that they had collected and said, all right, use this training data, come up with a solution, and whoever does a good job, they get $1 million prize. All right. And I think the people from Belcore, I think at that time it was a part of AT&T. So they did come up with a good algorithm, which is nothing but a variation on LSI SVD that we were talking last class. And they did get $1 million prize. All right. So that's what the recommender system is. So let's see. And of course, you've seen this. You go to Amazon, etc., and they basically give you this kind of recommendation. So what are the application areas? You can see that. I think I should have. Okay. All right. So there are all kinds of things. So for purchases, hotels, travel, this, that. All right. So everywhere these systems are there now. They're also on the social web. From LinkedIn, you might get messages, oh, you need to connect with this person and things like that. Again, that's part of the recommendation system working there. All right. Or jobs you may be interested in and things like that. All right. So what are some of the success stories of recommender systems? Why they become so popular? Some of these numbers are a little old. Okay. So these numbers are before 2020. All right. So 35% of purchases on Amazon are result of their recommender system. So that's what Amazon determined at one point, that's how much benefit they were getting from their recommendations. And basically, I think you keep reading about it, people going crazy on YouTube with all kinds of conspiracy theories. What is at the bottom of that? A recommendation system. So YouTube has a recommendation system that will push you, if you start liking those conspiracy theories or videos, it will keep on feeding you and you will be lost. So YouTube uses this, and 70% of the time people spend on YouTube is basically determined by the recommendation system. It's a kind of scary thing, 75% of what people watch on Netflix comes from recommendations. And 38% more click-through due to recommendations estimated by Google. So when people are surfing, looking for some products, that's the number. All right. So obviously, this is something that's really important in terms of making money, or in terms of doing few other things. So how do we do it? All right. So one is what we call as a collaborative filtering approach. What do we do in this approach? We look at users with similar preferences to predict how well the item under consideration will be received. So if there are two users and they have similar taste, similar choices, and we know that user number one has already bought something, chances are that user two will like the same item because they have similar taste, similar habits. All right. So that is what we call as collaborative filtering. Another one is content-based filtering. In this case, we look at the features of the item under consideration to predict how well it will be received. So this could apply very well to movies. For example, different people have, they like different types of movies. So if you can characterize different movies in terms of different features, you might say, all right, this person is known to like these kinds of movies. So maybe he or she will like this particular movie. All right. What one can do is one can incorporate on top of whatever else you're doing, demographic information. So in this case, we incorporate users' demographic information also to make a determination what he or she will buy or like. So let's look at some details of these approaches. So let's look at collaborative filtering. So collaborative filtering is a way of making suggestions for information or products based on community input. What are some of the examples of collaborative filtering? For example, New York Times publishes a bestsellers list. So that's basically a kind of recommendation system based on collaborative filtering. Or if you go into some wooded areas, you might find that there is a pathway that has been formed because a lot of people who go there travel on that particular path. All right. So that is a collaborative filtering. Or some of the sites will show you what are the top 10 papers or top 10 freeloads from that site, or top 10 downloads. So again, that's a collaborative filtering example. Or popular movies at a rental site or a store. Again, that's an example of collaborative filtering. Right. So how does one create a system doing collaborative filtering or using collaborative filtering? So one possibility is what we call as a user-based collaborative filtering. So what is the basic technique here? The basic technique is, let us say that we are given an active user. That is the person to whom we want to make a recommendation. All right. So let us say in this case, active user is Alice. And an item I. So there is an item that we want to push, or we want to determine whether we should push this item to this particular person or not. All right. So what we need to do is to figure out some kind of estimate whether this active user will like this item or not. If our estimate is that, yeah, the person will like it, then obviously we will push it. If we think that person will not like this item, then we don't need to push it. All right. So what we will do in this case, in user-based collaborative filtering, is that we find a set of users or peers, you can call them, who like the same items as Alice in the past and who have rated item I. So basically we look for other users who have done things similar to what Alice has done in the past. And these users also have bought this item. So we can, based on that, we can try to figure out what might be the response of this particular user. All right. So what we can do is we can use the average of their ratings to predict if Alice will like this item. And we can do this for all the items Alice has not seen. All right. So let's look at some numbers here to get a better idea. All right. So we have 4 users, user 1 to user 4, and then we have the active user in the first row, Alice. All right. There are 4 items, item 1, item 2, item 3, item 4, that all of these users, including the active user, has seen before, and they have rated them. Okay, so there is a response from them that they have done. All right. Then there is an item 5, which is under consideration for Alice. All right, so that is what we are trying to predict, whether she will like this item 5 or not. All right. For item 5, the other 4 users have given their ratings. All right. So basically, this is the data we have, and we'll try to figure out from this what are how likely Alice is going to rate this item or like this item. All right. This technique, by the way, is also known as memory-based filtering. All right. So let's see some details. So basically, we have to measure similarity of actions, all right, or similarities of users, all right. So how do we measure similarity? We have done that many times. So we'll basically go back to one of those techniques, all right. Now, in this example, I had 4 users, but in general, you have to have a question, how many users we should be looking for to base our prediction, all right. So that's in general. And how do we generate a prediction from the neighbors' ratings? All right. So basically, where the question mark is, that is what we are trying to figure out. Everything else is known to us. So let's see how we can do this. So let us call V sub ij as the vote of user I on item J. All right. So item J, how well it was liked by user I, that is represented by Vij. All right. I sub I is the items for which user I has voted. And the mean vote for user I is given by. Some people like to give good ratings to everybody. Some people are pretty, easy in terms of how they like things. Some people are a little more tough to please. All right. So it's always a good idea to get the mean rating and use that to do some kind of normalization. All right. So basically, we calculate the mean vote for user I, which can be calculated as shown. Then the predicted vote for active user A is a weighted sum given by this particular formula. So if you look at this formula, basically, it's a very simple concept. We are looking at the average voting that this active user has given in the past, and we are subtracting that from Vij to basically do the normalization, and the WAI is the weights that we want to assign. So basically, there are a number of users that are similar to our active user, but their level of similarity is different. So what we want to do is we want to take into account that level of similarity. All right. So basically, that's kind of simple formula. And the level of similarity can be done either using a simple binary rule, that is, if the user is within certain distance or below certain, above certain similarity value, then it is 1, otherwise it is 0. Or we can actually use an actual number based on Pearson's correlation coefficient, or using the cosine distance that we have used in the past. All right. So any of those formulas could be used to do the actual calculation for weighting that we want to use. All right. So if you want to use weight with the cosine, basically, the formula is pretty similar to what we have done. It's a cosine similarity. Again, normalized, you have to normalize it. So U and V are the two vectors describing two users. And basically, we are calculating the dot product. All right. With the Pearson correlation, formula is a little different, but it basically ends up with the similar concept or similar results. So if we were to apply some of these numbers in this case, we'll find that using Pearson's correlation, the similarity between Alice and user 1 is 0.85. Between Alice and user 2 is 0.70, -79. So basically, we can take those numbers, plug into the formulas, and get the final score. All right, so that's really what is done here. And I just shown you all the calculations. So you can take a look at them as you look at them later on. All right. Now, there are a number of tricks one can apply to improve the prediction function. All right. So not all neighbor ratings might be equally valuable. So one can look for agreement on commonly liked items is not so informative as agreement on controversial items. That is, if people agree most of the time, that doesn't give you much information. But if you look at their disagreement on certain points, that possibly tells you a little more. So what one can do is one can give more weights to items that have a higher variance in terms of their ratings, all right, instead of giving equal weight to all of them, all right. Value of number of co-rated items. Again, if you're looking at a pair of users and there are thousands of items, so how many items are common to their ratings with respect to the overall number of items they have rated? So again, that can give you some information. So one can use that, all right. And what should be the size of the neighborhood? Should we always be looking for some fixed similarity value, or should we making it adaptive, that we want to get top 7 neighbors or top 9 neighbors and things like that? All right. So there are variations of that kind that one can make to improve these results. All right. So we will stop here. I think I just want to stop here, and we will continue with the rest of the discussion on this item-based collaborative filtering and then a couple of other things. And then we will start talking about link analysis, especially get you some insight into the search engines and how the page rank system works and things like that. All right. So stop here. Thank you.